Hi, everyone. Before we start, we'll start the trailer of the Book of the Dead for those who've missed it.
Well, look at that. I didn't think you had it in you.
Tell me more about this place. You spent nearly 90 years there.
What? No. No, not there. The forest is just the lobby. That's where the entrance is. I've been thinking, how do I remember all this? When did I make these memories? You need a brain to make memories.
Your brain is now remembering things that never happened to you. Or to it. An enormous amount of neuron connections were formed since you came back. Decades worth of memory.
And there's one more thing you need to do.
Karen? Hey. Karen?
Yeah, sorry.
Are you alright?
Yes, I'm just tired.
Tell me. Did you see any of the others?
Yes. I damn near fainted. Even though he had told me about them.
You think that was one of them?
I know.
You're almost there.
You're the only one who woke up, Karen. One out of tens of thousands. Why?
Thank you. So thank you for joining us today for this talk about Book of the Dead. So first, I'm Julien Heymans. I come from Belgium, and I'm an environment artist. I've been working in the video game industry for around 7 years, and I joined Unity last year. Before that, I was working at IO Interactive on the last Hitman game. But today, we are here to talk about Book of the Dead. So more specifically, this talk will be about the creation of the content of this project. So we'll talk about how we created the assets, how we build the scene, how we set up the lighting, and the post-process, etc. Before we dig into the details, I wanted you guys to be the first to know that we are releasing Book of the Dead environment today on the Asset Store. So later you will be able to download it and dissect it yourself on your machines. Yes, don't miss the... Don't miss the keynote for the official announcement. So when our team started this project, our goal was to create a realistic dense forest using photogrammetry assets and scanned assets. We knew that it was not going to be an easy task. Creating a realistic forest in real time is not something that is very easy. But we wanted to challenge ourselves, and we wanted also maybe to try to push Unity further through this project. The timing was quite nice with the scriptable render pipeline that was being made and the HD render pipeline. So we could use this project to demonstrate what you can do with the HD render pipeline, and also we could participate in the test during its development. So when we started this project, the first thing we had to think about, of course, were the 3D assets. So we have mainly two sources for assets. One of them, as you've probably read before, is Quickcell. So doing a realistic forest like that was really just the perfect opportunity to work with them. We had already worked with them a little bit previously, but this was really kind of a cooperation. Those assets are really high quality, and they're also really easy to use. We are saving a lot of time. You can really get them into the engine and looking good quite fast. You just need to repack the textures, maybe tweak them a little bit, maybe improve a little bit the LODs, and there you have it. And also, all this import process, I think is also getting faster. I did not use it, but I know there is some Megascan bridge tool that is supposed to make that even faster with just a few clicks. So there are two kinds of assets coming from Quickcell. First, there are some assets coming from their library, and then there are assets that Quickcell actually produced just for us for this demo. They also allowed us to redistribute all of that. So in the package that will be on the asset store, you will be able to reuse all of the assets that are in there for yourself, for your own project, without any restrictions. Also, if you like these assets, there are some Megascan put some package on the asset store where you can buy them and create more scenes using that. Yes. So in addition to these assets from Megascan, our team wanted to produce our own photogrammetry assets. So the demo team already used that before, but we really decided to be more serious and to dive in for this project. So photogrammetry, what it is, for those who don't know, is the process of generating 3D objects and textures using simple 2D pictures taken with your camera. By any chance, has any people here already produced assets using photogrammetry? All right, there is a bunch of people. So I will go a bit. I will give you an overview of the process. So for all of you to understand a bit how it works. So the first step is, of course, to capture the project. Basically, you just go with your camera somewhere and you start taking pictures of the model that you want. You don't need a really expensive equipment to do that. Really, a mid-range DSLR camera just work fine, and maybe a tripod. You need your pictures to be very clear. And also, just an information, it's nice to use sometimes to use wider lens. Some people might think that because of the distortion, it's not very good, but actually the photogrammetry softwares handle it very well. If you go to scan something, there are some conditions. One of them is that you need some good weather condition. It needs to be dry, so no snow, no rain. It needs to be bright, and to get better results, it needs to be overcast. Basically, you want as least amount as possible of direct lighting on your model. And so what you are seeing here, the cliffs that you are seeing there, they're actually cliffs in Stockholm, and it's close by to where Veselin, or creative lead, lives. And so he basically went there with his camera, and he started taking a lot of pictures. So what you want is to take as many angles as you can of the model. If you forget some of the angles, then you won't have any information there. Also, you need your pictures to overlap. The photogrammetry software will need to basically figure out how to compose the whole geometry using these pictures, so they need to overlap. Something else is that you need to avoid change of lighting. So yes, overcast is nice. If you have clouds moving, you need to maybe act fast or choose the right moment. The more picture you have, the higher quality you will get for your final model. Our effect artist, Zdravko, was thinking that maybe acquiring a more expensive camera, a better camera would get him better scans, and actually did not really improve that much. It's really the amount of data or the amount of captures that you are using that will improve the quality of your mesh. Once you have all of these pictures, and this is actually quite a low amount for this kind of huge geometry. Once you have this, you need to generate the geometry using photogrammetry software. So here we are using for reality capture. So first you saw just the geometry, and now it's with the texture. So this geometry that you saw here is really heavy. It's not something you want to import in Unity, of course. So there are some extra steps that you need to go through before that. Yes. So first you need to clean your geometry. Like if you have vegetation, leaves, you will have some noise, so you'll need to clean your geometry. Also in the previous picture, there was a big lamp pole in front of your cliff. Of course, you want to remove that. Then you need to do retopology and UV unwrap like any geometry. Once you have all of this, you can bake your really high quality geometry onto your low poly geometry, and you will get all your textures. The albedo map that you get will need to be delete. So in PBR, you want your albedo to have basically no lighting information. So for that, there are several tools available, but Unity is providing one. It's called the Unity Delighting tool. There is the link here in the slide, and you can go there and there is a lot of information, but it's a quite easy tool to use. You basically need to input your geometry, your different maps, and it's doing the work for you. And this is the clip that you saw a few slides before, once it is in the editor. It's looking quite nice. I need to add something on that, is that no matter what resolution you are using for your geometry, for something that is big like that, for a huge cliff like that, you also want to use some detail map to bring really fine grain to it. And detail maps are supported by the HD render pipeline. So it's just a texture to plug in. So now I went through the photogrammetry process. Now I will talk a little bit more about the trees, more specifically. So the first step, of course, is to capture. So it's just what you saw before, but with the trees that you want to capture. You don't want to capture the whole trees, because it would be impossible. But so we scan the trunk, and we actually create kind of two objects out of that. So we have the stump, which is the part of the tree that is connected with the ground, and then the trunk. So we use a unique geometry for the stump, unique geometry and textures for the stump. So you can have on some of the assets, you can have the roots visible on top of the ground, and then a tiling texture for the rest of the trunk going up to the top. Once you have that, you need to create the textures of the branches. So we used textures from Quickcell Megascans. The thing is that they don't give you a whole tree branch as one texture. It's a lot of little part and leaves. So there is another step here where you need to, we did that in Photoshop, you need to assemble them together and then render them to create a bigger texture atlas for a whole branch. And then you can create the geometry like here. For the geometry of the textures, it's nice if you avoid having big flat surfaces. So in this example, what Zdravko or FX Artist did is just basically twisted the whole geometry, so you don't have really flat surfaces. So now we have everything we need. We have the geometry and the textures for the stump, for the trunk. We have the geometry and the texture for the branches, and we need to create the tree itself. There are several softwares to do that. We used GrowFX, which is a plugin for 3ds Max, and it works with a lot of splines that you need to set up to choose where do you want to start creating the branches, what direction do you want them to be pointing towards, and then you can generate your tree. The nice thing is that you can create really many trees using the same assets, using the same textures. You can create different types of trees to create variety in your scene. So now that's it. We had a nice looking tree that is static in our scene. And of course, we wanted to add some wind to it. So for that, we created a custom wind solution. It's vertex-based solution of a procedural wind animation. Why we did that? The thing is, these solutions are quite complex and work rarely for all the situation you want. So our situation works basically for all kinds of tree, for the trees that we have in our project, and probably not for any kinds of tree that you want. It would probably need a lot of extra work to have that working. So the way our tech lead Torbjörn made this shader is that we have 3 different levels of hierarchy in our tree. So we have the trunk, then we have a first level of branches that is connected to the trunk, and then we have a second level of branches that is connected to the first level of branches. And the shader, the information the shader will need to be able to animate this tree is it will need to know which is the pivot of every branches to know how to make the branch swing with the wind. So for me, my work was first to author the geometry. I did that in Maya. It's the picture on the right there. It's basically I need to assign a vertex color for the different level of hierarchy of the tree. So here we used the green vertex color. It was 0 for the trunk, between 0 and 1 for all the first level of branches, and then 1 for the second level of branches. In addition to that, we needed to give information to know where on the branch, the texture branch, where was the pivot of those. And so we use what we call a flutter mask, and it's the picture in the middle here. So you can see the branch, and I just quickly painted where the vertices of this branch are likely to be. And then basically we have all of the information we need to generate this pivot. And we used scripts, C# scripts in Unity that would then take all of this information, the vertex color and this flutter mask texture, and bake the pivot information for every vertex in the tree. Once you have that, you can start playing around. So here, yes, we can see the tree, and then I will start playing around with the elasticity of the trunk. Then I play around with the elasticity of the first level of branches, and then the second level of branches. Each of these level of hierarchy, they have this range property, which is basically the length. So the length of the trunk and first level of branch and second level of branch and so on. And then you can start playing with it and get something crazy. There is a lot of other properties that you need to set up in the wind object, which is information of the direction of the wind, the gust strength. There is literally 50 properties to get that to work. Yes, so we made some additional exploration and feature with the wind. The first one was for our system programmer, Malte. He had this idea to try to link the wind intensity with the volume of the wind when you play the level. And actually, it's surprising how well it looks. You will see if you download the project. When you hear a gust of wind, then suddenly all the grass and all the branches start moving around you. It's really nice, and it's really cheap to make it work. The other thing that we tried was to use a flow map, to generate a flow map to occlude the wind in the cavities of your scene. So that was quite a tedious process, and we used this for the trailer, and it was more of an exploration. So basically, we would export the scene, import it in 3ds Max, and then simulate fluids in the scene. So In the end, we did not use it for the project that we are releasing. The main reason is that it's quite a heavy work, and whenever you change your scene, you need to redo all this process. And also, in the end, it did not add that much to the scene. So maybe with other techniques in the future, some people could do something similar. But yeah, we did not keep it. Yes. So next, I will talk more about building the Book of the Dead environment. So that's the scene that will be shipped on the asset store. So that's what I've been working for the last month. Yes, the first thing I did when I started working on this project, and it's basically the same as what I do whenever I start working on any project before any new level, is to try to figure out the shape of the level to not get to try to prepare a bit, so your level will be at least somewhat optimized. So you need to think about just the view distance that you have. In this situation, it's to try to build some bottlenecks and corridors to occlude the view distance. Once you have this, then you can have some occlusion culling in your scene. So here on the right is the camera, and on the left you can see a debug view of the occlusion culling. So you can see what is rendered, and you can guess where the camera is looking. So I will disable the whole occlusion culling system, and then you will see all the other assets that are drawn. So everything that is culled, of course, will cost nothing to render. So it is something that is nice to have, definitely. All right. So when we released the project and we started looking on YouTube, the comments, a lot of people were saying that there is no way that this project was using the Unity legacy terrain system. Actually, it's not true. It's the case. We are using the legacy terrain, so it's quite some work to build the scene. But we did some change, though. We actually included the HD render pipeline layered shader to work with our terrain. So that's a little bit of a dirty integration, but since the project is released, that's something that you can play later today if you want to. You can already start using that. But there will be a clean integration of that, a proper integration of that in HDRP in the coming months. So what this layered shader brings is that the nice part of it, in my opinion, is that you can blend the different materials of your terrain using the height map information. So in this picture, I'm just changing the height map, the height offset of my different materials. So you can get a nicer blending than just the linear blending than you have in the legacy terrain shader. Also, a note for this project: all of the assets placed through the terrain object are set up as trees. The reason for that is the trees is the only way to get them to work with proper LOD support. Something else is that we have really a very large amount of assets spread all over the terrain. So in the end, you actually don't see that much. So here you have one of the scenes that you saw in the trailer before, and I'm going to remove different layers from it, so you can see how it looks under the hood. So I'm going to first remove all the tiny twigs that are on the ground. Then I'm going to remove all the hand-placed vegetation. Then all the vegetation painted through the terrain and the trees. So we still have a few trees left, and once you remove that, you have this, and yeah, the terrain it's just a tiling dirt textures, and you have a lot of other static objects there. The tricks that you saw before, maybe it's not obvious in the picture that you saw before, but when you will walk in the level and you start looking at the ground, you will see all these thousands of tricks there, and it really brings this level of detail up. So it would be completely impossible to place these tricks by hands. There are literally thousands of them. So the way we did that is we have this geometry. We have a set of tools, and so it's a simple flat geometry with alpha texture, and we actually set up some physics for them. And then we use this tool that our tech lead made that would first spawn all of these objects in our scene around a pivot, so it could be around a trunk of a tree. And then, so here I'm showing all of them have these colliders, which is quite insane to look at. And then we simulate the physics on them. So they will come and fall down a bit the way they would fall down in a real forest if it would fall from the trees. And once we have that, we will use a bake button, and it basically remove all of the colliders information from them. And we have this. So this is quite heavy geometry. So I understand some people might be scared when they see that. But actually, they are all materials with alpha tests. So when you kind of get 10 to 15 meters away from them, they will nearly disappear with the bitmap. So you can load them out really fast. So in the end, it's not that heavy to run to have in the level. Just a note, so we need specific collision for these tricks to fall properly on the ground. We have colliders for the player controller, and we needed another level of colliders that is more precise on the rock. And you just need to have the twigs and this collider to be in the same layer. So the really defined and precise collision for the rocks and for all the assets are never used at runtime when you play the game. So the lighting in this project. The lighting solution we use is to use indirect global illumination with real-time direct lighting. So what that means is that we have everything that is indirect lighting in this project is mostly the effect from the sky is baked. But everything that is direct lighting from the sun directly is real-time. So that gives us some freedom because we have these two different parts. We can actually animate the sun, and we can change a little bit its color and its intensity. But I would not go crazy with that, because if you offset it too much from the baked information, it will stop matching. So you cannot have a day and night cycle with this solution without extra work. We use light maps, but actually mostly for the terrain and for large, not too detailed assets. And we use light probes lighting for the rest of the assets. It will give you a lot, at least for this project, when you have these rocks with these really sharp angles, light map kind of make it look a bit too flat. So we use light probes for that. Occlusion probes is a solution that was developed by our graphic programmer, Robert, for this project. And it has been integrated as an API already in Unity since 18.1, but there is no UI for that. But I know that they are working on it. So what is it and how it works? It's basically a volume that you place in your scene. It's quite easy to use. It's a big volume. You just make it englobe a big part of your level, and you set a density information in X, Y, and Z. And when you will bake the lighting, these volumes will be filled with occlusion probes that will kind of sample the amount of sky that it can see. And it will give you basically a volumetric information of the lighting. So when you have two trees that are close to each other, you will have occlusion probes will see a lot less of the sky with all the branches, and then it will look darker there. So here you can see the debug view of debug view called sky occlusion. That lets you see where you have this, what is the effect of the occlusion probes on your scene. So here you can see the scene without any occlusion probes. So basically all the trees in this scene, they have one lighting information for the whole tree, for the whole height of the tree. And so they look kind of flat. And then when you add the occlusion probes, it really brings this depth in the lighting of the scene. So yes, this solution is in this project. So it will be integrated later in Unity properly, but you can already use our solution in your project if you want to look at it. For the post-process, we are using some in-house, some built-in Unity solution like the post-process stack, but we also use some custom. One of them is the atmospheric scattering. That's a solution that that existed already in the Blacksmith demo previously, and we ported it to HD render pipeline. And there is a link there if you want to see more information about it. So something that you need to know is that an atmospheric scattering solution is being developed for HD render pipeline, but it was just not ready at the time where we were working on this demo. So that's why we use this solution. I don't know exactly when it's supposed to come out, but I think it's already in beta. In 18.2 that will be released. Yes. We use, of course, the transmission from the HD render pipeline. There is not much to say about it. It really brings a lot. You can see here on the picture, I'm toggling it on and off for the grass, and you can see how much it brings to the scene. It's pretty simple. It's pretty the same as you can see elsewhere in the industry. You just input thickness maps for all your vegetation and set where the texture should be thick or thin, and then it will just give you this result. Of course, with a lot of tweaking. We have some other post-process, some that I won't mention because I don't understand everything, but we are using some grass occlusion, which is kind of the cherry on the cake. It's really just to add thin occlusion on all the small vegetation assets that is spread on the terrain. And then we use something that we call area volumes. So it's building on the core volumes system that exists in SRP. And it's basically like a post-process volumes. So a post-process volumes, for example, you have a sphere and you have this specific post-process in this sphere, and when you get out of it, you can fade from one post-process effect to another. And this system is similar, except that it's driving other properties from other objects. In our case, for this project, it's driving the settings of the directional light, of the atmospheric scattering, and the wind. So that's why when you will walk in the scene, you will see that the light will change, and the atmospheric scattering will change, and the wind intensity will change, and that's how we did it. So I will have a quick word about the optimization. So there is a lot of optimization that has been done on the code side. So this project is running on Xbox and on Xbox One and on PS4. So there was a lot of optimization done on the code side, but that's not something that I can explain for you. If you are interested in that, though, there is a talk tomorrow specifically about this. But for us, so I had to see how much I could improve the scene on the content side. So of course, you need to use LODs. There is no way around it. But you have this checkbox in the LODs that is LOD crossfades, and it's really nice and it's really tempting because it makes the transition between the LOD a lot better. It will smoothly go from one to the other. Crossfade from one to the other. So it's really nice, but we realized how heavy it was. It is going to increase the amount of draw calls from your project. So for our project, we try to disable it whenever we can. So you will have, sometimes it's better to have some pops than have a bad frame rate. For some objects, we use the object space normal. So yes, when you have the LOD popping from going from one LOD to the other, one of the reasons for that is often simply when you are using tangent space normal maps, you don't have the same amount of geometry, and all the normals of your surface of your geometry will change, and so the lighting will look different on your asset. One way what we used was to use object space normal maps. So then this does not matter. The normals of your surface will not matter, and you can go really from one LOD to the other without seeing these pops. I need to warn though, so when you use object space normal maps, you will lose quality. But actually for a project and for our assets with all these rocks and with all these kind of noisy surfaces, it's working pretty nice. We don't really notice a loss of quality. But I would probably not use that for a hard surface or anything like that. I mean, I never tried at least. I would probably not do that. So yes, then it's better to use occlusion culling. That's the video I showed you at the beginning. but you need to be worried about something else. So it's not only what's on screen. I mean, it's probably obvious for the coders in here, but I was quite surprised when we realized that in our project, one of the location and camera angle where we had really bad frame rate was actually what we saw on camera was actually not very impressive compared to the rest of the scene. And actually, the problem was the draw call that were caused by the creation of the shadow maps for the real-time lighting. So it was actually all the trees behind the camera and the trees further away that were not even visible that were causing all of these draw calls. There is no magic solution to go around that. You can, of course, delete the objects that you don't need. You can improve your LODs, but there are still something else that I tried was to. We had a lot of small grass patch, like thousands of them on a small part of the terrain, and I basically created very large grass patch. So instead of having hundreds of them, I would have 20 of them on the ground. It has some downside also because since you have this really large grass patch, it's really hard to place precisely. So it will clip with rocks on the ground, for example. Something else we did was to, so there is this system in Unity that is called layer culling. There is no UI for that, but it exists in Unity. And it basically allows you to cull objects depending on which layer they are set to and depending on their distance. And we so we applied a layer for our small grass object or large tree, and etc. And so we were sure that it's going to cull no matter what were the LOD settings. And we added something to that was we allowed to cull the shadows for this object. So for example, a lot of our small bushes on the ground, they will stop casting shadow at a specific distance in front of you, and then they will be culled even further. That way we could reduce the draw call from the generation of the shadow maps. Yes, so with all of this optimization, it's now running on Xbox One and PS4, so if you are interested, you could totally check out the Microsoft and the Sony booths there and walk in the forest yourself. Also, if you are interested into getting more information about the creation of this project, you should check out the landing page on the Unity website. So it's unity3d.com/Book of the Dead, and we'll have a lot. We have a lot of. For now, we have 3 different blog posts about the concept art, about the character art, about the VFX, the photogrammetry of our projects, and the trees, etc. So you should totally check that out. And that's it. Thank you.